Let's talk about something you probably use every day without even thinking about it, the elevator. But what if I told you that this humble machine, this box in a shaft, is on the brink of its biggest change in over a century and a half? We're going to dive in. Seriously, it's wild when you think about it. Ever since Elisha Otis came up with his famous safety brake way back in 1852, the basic idea of an elevator hasn't really changed. Yeah, we've made them faster, we've made them shinier, but at its heart, it's still just a box on a string. And that box on a string idea is the whole problem. You've got these super heavy steel cables pulling a single car up and down. But as buildings get taller and taller, those cables get so ridiculously long and heavy, they can barely even support their own weight. It creates this invisible ceiling on just how high we can possibly build. But the new way? Oh, it's a completely different animal. So how do you break through that ceiling? Well, it's simple, really. You get rid of the thing that's holding you back. The cable. You just get rid of it completely. The solution is magnetic levitation, or Maglev, using the pure power of magnets to move the elevator cars. This one change shatters that 160-year-old limit and opens up a whole new world. So, how does this magic actually work? Well, the core idea is surprisingly clever. Imagine taking a regular electric motor, kind of slicing it open, and unrolling it all the way up the elevator shaft. The coils in the wall, that's the stator, create this moving magnetic wave. And the magnets on the car itself, the mover, just ride that wave. No ropes, no pulleys, just silent, powerful electromagnetic force. Okay, so all this freedom from cables, what does it get us? What's the real payoff? Well, how about this number? A 50. That's 50% increase in passenger capacity. That is a massive leap in efficiency. But how is that even possible? This is where it gets really cool. Once you're not tied to one car on one rope, you can have multiple cars running in the very same shaft. They operate in a continuous loop. It's literally a vertical subway system. More people get moved, you spend way less time waiting around, and this is a huge deal for architects. The entire system takes up a lot less space in the building. Getting rid of cables is incredible for sure, but believe it or not, that's only half the story. This technology unlocks something that sounds like it's straight out of science fiction. This is where we completely break away from that simple up and down model forever. Check this out. The elevator car zips up to an intersection in the shaft. A special section of the track, they call it an exchanger, just rotates 90 degrees. And boom, the car is now moving sideways. It's not just an elevator anymore. It's a true, honest-to-goodness transit system inside the building itself. Now, you might be asking, okay, moving sideways is neat, but why does it matter so much? Well, take a look at this. In the super tall skyscrapers we build today, that massive concrete core right in the middle, the part with all the elevator shafts, it can eat up to 40% of the building's entire floor plan. That is a mind-boggling amount of expensive real estate that's basically just a glorified hallway. But look at the difference with the Maglev system. Because the shafts are smaller and so much more efficient, all that lost space, you get it back. The difference is just stark. This hands architects a tremendous amount of valuable square footage back, which means more room for offices, apartments, you name it. And this quote right here, it just nails it. For 100 years, buildings have been designed around that giant solid trunk in the middle. But by removing that restriction, designers are suddenly free to dream up entirely new shapes for our cities. Buildings that loop, buildings that arch, buildings that connect in ways we've only ever seen in concept art. And that leads to this, the ultimate vision. The Maglev elevator becomes the circulatory system for a 3D city. You could literally take an elevator up one tower, travel horizontally across the sky bridge to another building, and then go down, all without ever setting foot outside. It's a vision of a truly interconnected vertical world. Of course, if this technology is so revolutionary, why isn't it everywhere yet? And that's a fair question. There are a few major hurdles. For one, the initial cost is still really high. All those magnets and sensors don't come cheap. Then you have regulations. All of our safety codes were written for cables. They have to be completely rethought for this. And finally, it's complex. You're basically running an air traffic control system for elevators inside a building, and that needs some incredibly sophisticated AI. So let's end with this thought. For 160 years, we've only been solving one dimension of movement in our buildings. The elevator conquered up. But this new era of technology is about conquering the horizontal at the same time, fusing them into one seamless network. It forces us to ask, what will our cities look like when our buildings are no longer just tall, but truly connected?